Good day, everyone. We are Group 9 and 10, and today we are going to present our SIF2009 Electronic Practical project, the Parcel Alloc Anti-Theft. Our team consists of Eu Jin, Shrianish Sambath, Wong Huimin, and Khoo Elaine. In the current age of e-commerce, we identified three major issues. First, parcel theft, where unauthorized access is easy due to little to no physical security. Second, a lack of real-time notification, meaning tenants don't often know when a parcel arrives or if someone is tampering with it. Lastly, inefficient organization, as there are usually no digital records of deliveries.
The objective of our parcel logs are, firstly, to send real-time alerts to owner through Telegram app via Raspberry Pi. Second, to enhance the physical security of parcel log through solenoid-based locking via Arduino Uno. And thirdly, to allow only authorized users to access the parcel log via RFID reader. By achieving the three objectives, our parcel log has achieved the three SDG goals developed by the United Nations, which are SDG 7, SDG 9, and also SDG 11. Methodology. To create our parcel log, we have used the hardware and component as listed below. After that, we plotted a schematic diagram to organize the connection of all our electrical circuits. Lastly, we assembled the circuit according to our schematic diagram and also put in the codes into the Arduino IDE and Raspberry Pi imager in order for the code to run on the electrical components.
Now I will present the result of our project. Our smart parcel lock system operates in two main modes, which are postman mode and owner mode. First, I will explain the postman mode. In this mode, we successfully achieve our objective of sending real-time alerts to the owner through the Telegram application using a Raspberry Pi. When the postman delivers a parcel, a Telegram bot sends a real-time notification to the owner to inform them that the parcel has been delivered. This ensures that the owner receives immediate confirmation of delivery. Now, let us look at the details by watching this video.
To place the parcel into the lock system, what I would have to do is use the Telegram bot. And here I would send the command /start. After that, I will have to key in the unit number. So for example, if the tenant was staying in unit 0205, I would send it like this. And the system will automatically retrieve the tenant staying in that unit so that I can confirm that I'm keying in the right number. If I click yes, I can now key in the parcel number. So let's say, for example, the parcel is numbered 567. I would then upload a photo of the parcel. So let's say, for example, it is this drink right here. Right. So the system automatically opens the lock so that the door is open, and it starts beeping after 3 seconds if the door is not closed. So if I place the magnet on the read switch, which is the same as closing the door, the lock closes back on itself.
Next, I will explain the owner mode. In this mode, the system determines whether a valid access card is used by reading the UID number through the RFID reader. This mode can be divided into two scenarios. The first scenario occurs when an incorrect access card is used. When the UID number is not recognized, the system denies access. In this situation, the buzzer will beep and the solenoid knob remain closed and the LED indicator stays red. Through this result, we successfully achieved our objective to enhance physical security through solenoid-based locking controlled by the Arduino Uno, as unauthorized access is effectively prevented. Now, let us watch the video demonstration. Okay. The second scenario occurs when a correct access card is used. When the system detects a valid UID number, the solenoid lock is activated and open, allowing access to the parcel. At the same time, the LED indicators change from red to green and the buzzers remain on until the door is properly closed. This result demonstrates that we have achieved our objective to allow only authorized users to access the system via the RFID reader. Once again, let us watch the video demonstration.
Door open, door closed.
I shall then move on to the discussion section, comparative analysis. We're going to compare basic RFID to typical smart locks and then our smart lock. The basic RFID doesn't have much security, can be forced open easily, and there's no knowing whether it's a tenant or the delivery or the thief, and there's also no IoT integration. For typical smart locks that you can buy online or just in any store, the security is typically a two-step verification process where the delivery guy has to get information from their parent company to actually open it, as well as typically the picture of the parcel. There's unfortunately no real struggle when it's trying to be forced open. And the tenant also actually has to go through the similar two-step process that the delivery guy goes through, so it's quite annoying for the tenant. And there's also no IoT integration. Our smart lock, however, security is very high, as the deliveryman has to take a picture of their parcel, as well as know the exact house number and the name of the tenant, so that they can deliver effectively. We also have a feature to prevent false opening from thieves or unwanted tenants, because it auto locks and the buzzer becomes on. For the tenant, instead of going for the two-step process, which is inefficient, they just have to have a card, so they scan the card on the RFID and it opens immediately. And we also have IT integration such that the tenant will get notifications whether the delivery has been delivered, as well as immediate knowing when the parcel has arrived.
And now I'll be presenting on some of the sources of error that we faced throughout this mini project. The first one is in integrating Wi-Fi into our project. And originally, we wanted to use an ESP32 microcontroller, which is a component that allows for both Bluetooth and Wi-Fi, in which case we wanted to use the Wi-Fi component to integrate the IoT or Internet of Things into our parcel lock system. But due to issues in connecting to the Wi-Fi using this microcontroller, we decided instead to use a Raspberry Pi, which would feed commands after receiving them from the Telegram into the Arduino. The second issue we faced was through wiring issues. And because an electronic schematic was not created until late into our project, a lot of times when we tried to connect all the connections, such as the pins and components, there were oftentimes careless mistakes that were made. And also, furthermore, some of the times the components with many pins were not securely connected to the breadboard, either due to the way we connected the pins or even due to the age and wear and tear of the breadboard, causing unexpected errors to pop up even when the coding or supposed connections were correct. This was solved by checking through all the connections whenever the parcel lock failed unexpectedly. And lastly, we also had to deal with communication between two different microcontrollers, being the Arduino and the Raspberry Pi, which could sometimes lead to bugs in the software or coding due to differences in the communication scripts, as the Arduino ran on C++ while the Raspberry Pi ran on Python. There was also some latency whenever the Pi sent commands to the Arduino, resulting in the Arduino sometimes failing.
In conclusion, the smart parcel lock system was successfully designed and implemented using a Raspberry Pi as the main controller. The integration of key hardware components, including the RFID reader, magnetic reed switch, and solenoid lock, effectively enhanced the security of delivered parcel by preventing unauthorized access. In addition, Python-based software was successfully developed to manage and control the system logic, enabling smooth transition between the different operation modes of the parcel lock. Overall, the project objective was achieved and the system demonstrated a practical and reliable solution to address parcel theft and security issues.
Now, I would like to share a bit about the appendix, with the first one being the Raspberry Pi code. The code allows for three main features, with the first one being delivery management, whereby the Pi communicates with the delivery person to allow for it to authenticate the unit number of the tenant, to log the ID of the parcel, as well as to request and log in the photo proof of the delivery. It also allows Arduino control by sending signals to the Arduino whenever the parcel lock is meant to be unlocked after verification. Thirdly, there's also Internet of Things or IoT integration to allow for notifications to be sent to the tenant's Telegram account after a delivery is made, so that the tenant is able to see both the photo of the parcel as well as the status of the delivery. This code was written in C++ in about 178 lines. The second appendix is the Arduino Uno code, which also has three different main features. The first one is the control of the solenoid lock, so that whenever the correct RFID tag or card is used, or when the Arduino receives commands from the Raspberry Pi, it is unlocked, so that the parcel can either be placed into the box or taken out of it. There are also three smart states whereby the door is able to detect whenever it has been locked and unlocked, so that whenever it is open for a certain amount of time, it will start to beep, alerting that it has not been closed securely. Lastly, there's also been a stability fix with the code, whereby the RFID reader is reinitialized every time it is used. This is to help to prevent it from crashing whenever there are voltage fluctuations, for example, when it is spammed too many times in a short duration of time. This code for the Arduino was written in Python in 182 lines. That's all for the video. Thank you so much for watching.